So as Elisabetta said, I'm Riccardo Filomena, and I work in AI and digital field. But my background is a mechanical engineer, so that's led me to have a pragmatic approach to the problem and to digitalization topic in specific. And I'll try to share my attitude during the presentation, I hope so. I'll try to be quick and clear, so I will start to introducing Mann's philosophy and his role into the battery ecosystem, European battery ecosystem. Then I'll touch the main focus of the presentation, that is the digitalization, and what is this impact in the battery value chain. Then I will go deep dive into details with modeling and simulation. I will talk also about digital twin, and I'm going to share also a couple of practical examples that we achieve in Mann's. And then finally, some conclusion and a quick recap of digitalization meaning, benefits, challenges, and perspective. Okay. So as my colleagues say, the European battery landscape is growing really fast. And in the last year, we were witnesses about technologies improvement in innovations, such as on software, so with artificial intelligence, machine learning, digital twin, but also in hardware. And this is leading us to create the first gigafactories in Europe. And that's when, at the beginning of 2019, Mann's asked itself a question: what is the key value or the main point to be able to create and to be a part of an European journey and to develop in the right way? The answer for us is the cooperation. And so sharing knowledge, sharing know-how, hopefully sharing also data. We strongly believe that being a part of something is the main key to achieve our goals. So that's why Mann's is a part or is an enthusiastic stakeholder for the main European project and cooperative associations such as Horizon Europe, Batteries European Partnership already mentioned. And last but not least, we are also part of APCA. That is a 6 years long project that is start from a strong R&D phase, in which phase we are going to develop and to create a new solution. And this following step is to the industrial deployment. So we would like to industrialize these achievements and finally to reach in 2027 the mass production, and so gigafactories. So we mentioned about digitalization, but what does it mean for Mann's and how we see it as a particular beneficial into the layers of the battery value chain? I'll try to explain to this, to answer to this question in this simple slide. We divided in 3 layers the part of this value chain, but we also wanted to represent not only the step of the process, but also the actors of this system. So we start with a layer of discovery and R&D. In this case, the software and the AI can help us to improve the algorithm and accelerate the material discoveries, as our colleague explained before. And we also think that developing better models can help us to predict the behaviors of the processes and the batteries and to improve the design phase of this battery value chain. The middle layer, the first layer, of course, is on charge of battery manufacturer. The middle layer is more on Mann's, as example, in charge as a machine automatic manufacturer. So we are used to take in consideration production, usage, and maintenance. So in this case, we use digital twin to improve the process optimization and to improve also the efficiency of the production. All of this data is really important to gather all the data together and orchestrate them really well, because all of this data can lead us to better understand the processes, the bottleneck, and to improve the predictive maintenance, and so achieving the predictive one, and maybe testing new sensor or new analytic methods. Finally, the end of life. So This layer is maybe on charge of recycling phase of the batteries, and is based on traceability. So all the data that I mentioned before should be gathered and collected and shared in order to be really transparent in the application and the life cycle of the battery. Now I'm gonna deep dive into the modeling and simulation. I'll talk about digital twin. I'm gonna give you the basics of the concepts, and then I'll show you a couple of examples. Nothing special, we probably already know the concept, but what does it mean, digital twin in months? It's a virtual replica of a complex real system. Everything is based or start from the simulation, so simulation of the processes, mechanical, thermodynamic, fluid dynamic. All of these processes enable us to create a 3D representation of the complex system. For months, the complex system means an automatic machine. And this model is the base to improve and to simulate the behaviors of the processes and to simulate the bottleneck and the problems even before building the machine. That should lead us to a better physical devices. And this is the first main step, so from digital to the real case. But it's not the end of the process, because these devices are designed to generate a huge amount of data that are used as a feedback, to improving the models in a continuous improvement virtuous cycle. Of course, the aim is to describe it, to understand better the processes, and also to understand how to monitor them in a better way. How can we use this concept in the industry, in manufacturing field? On the right, you can see a quite scheme of in which the inner level is the process I already mentioned, process digital twin. So simulating the physics behind the events and the process. These help us to optimize the parameter, to understand their impact on the final result, that is always the yield and the quality, of course. All of these processes constitute a machine, a full machine digital twin is made to simulate the behavior of a complex system and to understand the malfunctions before they happen in the real scenario. Of course, multiple machines constitute an entire production line. So on this level, we are going to simulate the production flow. So we are more focused on the efficiency, on the quality, on the availability, and the OE in general. Now I'm going to show you a couple of practical examples of what we achieve in months. Here you can see a digital replica of a winder automatic machine that is designed to assemble cylindrical cell. So it's a roll-to-roll machine. And in this case, we create cinematic and dynamic models that allow us to simulate and to perform the virtual commissioning of the mechanical design part. So we can really understand soon if we made some wrong decision in that part, watching the models running. But it's not only the mechanical team that has most the benefit of this solution, but also the software, because this is not just a CAD, it's a complete model that is linked to the PLC project. So we are able to move the machine with the PLC, and so we are going to test and to develop the software even before having the hardwares, and that usually take a lot of time. So the possibility to test this, as you can imagine, is the key to decrease the commissioning time, so low time wasted and reduce waste of cost. The next step on this study is to simulate also the process, because this is a cinematic and dynamical mechanic, but we want also to simulate the web material, so being able to understand how the material is affected by dynamics of the machine, and this should help us to improve the process design phase. The second is more related to the outer layer of the shell, and this on production line. This is a project that is within Horizon project framework. So we simulate a full line. Actually, we try to simulate a gigafactory, and so lines and lines. We use the plant simulator software. The idea is to be able to understand the bottleneck of the lines. So in this case, the input of the model were working hours, cycle times, quality, part product, footprint, etc. The final target is to optimize the process flow. On the right, you can see a block scheme, block diagram. Once on the top you can see before, and on the bottom you can see after the optimization. For example, let's take in consideration the yellow block. They are the time that they means that about the time the machine are stuck waiting because of a previous machine or a following machine. Of course, it's something that we would like to avoid in order to not waste time. And then we were able to reduce this time and this and other wasting of times, and improving the efficiency. Here, why this is so important? Because as you can imagine, at the scale of a gigafactory, even a small percentage of improving in quality or in performance means an enormous reducing of the cost, the time, but not only about efficiency, because not wasting materials also means being more sustainable in the European environment. So this is a double win target that it's really interesting to achieve. The biggest challenge in this, but also in other cases, and I suppose in all of your work, are retrieving the right amount of data, and especially the right level, quality level of the data. That's why, actually, currently we are working on improving the monitoring phase of the digitalization. Actually, that's my current job in Mans. So we are working together with the client to improve the capability to understand the machine state, because we figure out that there's a big effect on the production performance, but it's not easy, because maybe also answering to the previous question, we, as a partner of a final part of the production, we have to deal a lot with the human effect. So we have the operators, we still not have, even if it's an automatic production line, we have a lot of cases that have to be dealt, and so we need to find the right way to handle the availability, performance in the right way. Finally, let's draw some conclusion. We talk about digitalization. We talk about their impact and how their solution can affect the battery value chain. So let's sum up about the benefits. We talk about reduce the time to market with the digital twin, so simulating the system before even build it. This leads also to increase the reliability, because having the opportunity to test a lot before in virtual commissioning and then in the real commissioning allow us to detect more anomalies in the processes. The traceability, of course, guarantee us to provide a transparent cycle life assessment, and this is really important for us and to communicate each other to have a fulfilled battery cycle life. This also leads to a side effect that, in my opinion, maybe it's the most important one. So building a stronger European battery value chain. So increasing the collaboration, increasing the sharing of the data, because everybody can have benefits of sharing data and sharing the knowledge. And unluckily, this best positive part, benefit, is strictly connected with the biggest challenge, in my opinion. So, because it's true that we have to improve the accuracy of the model, and before that, retrieving the right data and the quality of the data. But I think that it's really, really important to improve and to create a digital culture in the companies, because this is not a standalone journey from just in charge of a small teams or some employees. Everybody can contribute, and everybody should be empowered of this, the meaning of this, to help and to reach the perspective that we would like to achieve. So maybe in the future, some methods, some self-optimizing processes that automatically detect some anomalies and fix them, or give us the hint to fix them, and in general to have a more holistic system and network for the production. And that's it. So thank you for, I don't know if I'm in time or not, but it's over.
So thank you very much, Ricardo, for sharing your point of view, point of view, by the way. What we see is that this holistic view, what we were also seeing in the material level digitalization, so apparently it's crucial. So thank you very much. Is there any question from the audience?
Thank you, Ricardo, for the presentation. I'm Frederick, I guess, from CETEC Energy Storage. I was wondering, when you build a digital twin for your machine, you are not considering chemistries. Do you think a digital twin can be valid for all type of chemistries and technologies, thinking on different generation of batteries, such as well solid state and lithium-ion batteries?
Yes, it's as I said, it's cinematic and dynamic models that allow us to improve the design phase, and of course being able to elaborate and to simulate the chemical process and the mechanical process of the material is really, really big point for us, and we are currently working on defining a discrete time model to being able to perform the web, but it's a continuous movement, so it's not easy, it's big challenges. But we would like to achieve this really soon, because I think that we're still missing maybe the process improving design, that, as we know, if we work better at the beginning, we will have an easy job at the end of the process. So that's our aim. Thank you.